All right, so the last part of this video is going to be on the last page of 7a, and this is kind of the putting it all together. So in this one, I'm not going to worry about these graphs down here. Really what I want to do is figure out how do these transformations change that point. And the idea is I'm going to take this point and then stretch it by 2, and then take that point and shift it 3 to the left and 5 up, and continue on, and it's sort of a chain reaction, and the goal is to figure out where the final point ends up being. So let's look at what these things do. So a horizontal stretch by a factor of 2 means you're going to take the point that you have, and if I'm only stretching it out horizontally, only the x values are going to change. So I'm going to double the x but keep the y the same. So in fact, I'll just write the rules here informally. Double x, right? When I shift it 3 to the left and 5 up, 3 to the left means I'm going to have to subtract 3 from x, and then 5 units up means add 5 to y. If I'm vertically shrinking by a half, that means that I'm only pushing things in towards the middle vertically. So that's going to be multiply y by 1/2. When you reflect across the y-axis, so I'll use one of these graphs down here. So if you reflect across the y-axis, notice the only thing that changes here, the y values stay the same. It's the x values that change. So this one would be change sign for x. And then the last thing, rotate 90 about the origin. That's the one where you take xy. We just did this. Take xy and turn it into negative yx. Okay, so let's apply that by starting with our point C. So C is at 3, negative 1. So if the first step is stretch it by a factor of 2, you have to double the x. So if I double the x, I get 6, and then I keep the y the same. Then I'm going to shift it 3 to the left and 5 up. So I'm taking this point now and subtracting 3 from the x and adding 5 to the y. So negative 1 plus 5 is 4. Then I'm vertically shrinking by a factor of a half. So I'm going to take the y value and shrink that by a half, so it's multiplying it by a half. I'm going to get 3, 2. Then I'm going to reflect it across the y-axis, which means change the sign for the x value. So instead of 3, 2, I'm going to get negative 3, 2. And then the rotation by 90 degrees. When I don't mention a direction, it's assumed that it's counterclockwise. So that's going to be, it's kind of like flip the x and y and then throw a negative in front. So flip the x and y and then throw a negative in front. So there's my final point. That's going to be my C prime. Okay. And then the one other thing we did in class, we didn't bother with the graphs. The graphs were there to show you what happens at each step, but I'm not worried about that. So the last thing was to perform the same transformations, but now do it on 3 other points. And really all I wanted to do was preview how to do it with some point that has no specific numbers in it. So I'm going to, let's see if this works. I'm going to take this, edit, copy. I'm going to paste it down here somewhere so we can see it. Edit, paste. Okay, let me move this over. So I'm just going to put it down here. Okay, so if we did the same thing, but with the point A, comma B. So the first thing was stretch it by 2, which means double the x value. So that's going to turn into 2A, comma B. And then we're going to go 3 to the left and 5 up. So I got to subtract 3 from the x value. So 2A minus 3. And then add 5 to the y value. So B plus 5. And then we're going to shrink it by a factor of a half. So I multiply the y by a half. Well, there's my new y value. The x stays the same. And then multiplying by a half is the same as dividing by 2. So I'll do b plus 5 all over 2. Okay, then reflect about the y-axis, change the sign for x. So this is going to turn into negative 2a minus 3, comma, b plus 5 over 2. And then the last step, I'll just go down like this. So the last step is rotate 90 degrees counterclockwise about the origin. You flip the x and y and then throw a negative in front of the first coordinate here. So if we switch them, we get b plus 5 over 2, and then negative 2a minus 3. And then you got to throw a negative in front of that first coordinate. So right there, I'll put this in parentheses so it's more obvious. So that means that AB ultimately turns into this guy right here, negative b plus 5 over 2, comma, negative 2a minus 3. And so the reason this is good is if you had to do this process for like 6 points or 5 points, a bunch of points, it's somewhat annoying to go through it every single time with every point. But if you do it one time with this general point that has no specific numbers, you get a formula for what you can just plug those numbers into and you're done. So like we'll do it with the point that we already checked, 3, negative 1. C was 3, negative 1. So if I try this right here, let me get rid of this now. So cut. Oh. So if I try it with 3, negative 1, A is 3, B is negative 1, and then that's going to turn into negative b plus 5 over 2, so negative 1 plus 5 over 2, comma, negative, and then 2a minus 3 is 2 times 3 minus 3. And if you work that out a little bit, so this turns into negative, let's see, that'll be 4 over 2, so negative 2, comma, and then this inside the parentheses here is 6 minus 3 with a negative in front, negative 2, negative 3. Well, that's what we got here. So so if you had to do it several times, and in this case we were going to do it with these 3 points, but we ran out of time in class. The idea is you can just do it once with the general point, and then use that as your blueprint for how to plug in any point that you want and see where it ends up. Okay, so I hope that helps a little bit, and I'll see you guys in class.